All right. As promised, we are going to look at what? We're going to look at complements. All right. It's always safe practice to start with the what? With the decimal. Why? Once people get a picture of what's going on, decimal is our language. So once people are speaking your language, it's always easier. All right. Obviously, I'm not talking about languages. I'm talking about as in our number language. So everyone being accustomed to decimal, to counting in decimal, when they understand things in decimal, it's always easier now to what? To transfer that knowledge to the other bases. So what I'll do then, I'll look at what? I'll look at decimal complements, so that at least when I then try to teach the what? Try to show how the other complements, how the binary complements relate, it will be easy to understand. So let's try decimal complements. Okay, what is their use really? The complements actually facilitate the computer can primarily just add. It cannot do anything else other than add. So what complements do is we try to manipulate a situation where, all right, since the computer can only add, we try to manipulate that addition to say, okay, how do we achieve other what stuff like all right, it's easy to multiply because multiply is adding so many times, so round is taken care of. So as you saw with the process that the computer follows, it keeps checking. If it's multiplying, it keeps checking if the divider, if the multiplier is a 1 or a 0. If it's a 1, it just adds the what? It just adds the original number that we're multiplying. It just adds it again, so it keeps adding. So multiplying is just a sequence of what? Of addition, so it's not a problem. The only problem now is when it comes to what? To dividing, as you saw. Yeah, to subtracting itself, subtracting and dividing. Because subtracting is, computer is not really able to do that. What we do, we then play around, even with the hardware. What we do, we play around and get what we call especially inverters really that do the complementing. We play around with what we call the complementing circuit. We create a complementing circuit, so that then now our number, instead of being subtracted, will then be added. Okay, even though, okay, we may then argue that probably it can then subtract, because we have made this hardware via complementer that will basically complement via an inverter that will basically complement and then do the addition. So ultimately, what will do the job is the adding circuit. But the adding circuit is first manipulated to what? To first complement, so it can then do the add while it's actually performing a subtraction. What about division? Division is obviously, as we saw, it's obviously subtracting so many times. So if we can then manipulate the adding process to do to do subtraction, we can therefore do this repeatedly and achieve the division. Now I'm going to go into the complement and show you how we can then manipulate what? Addition to actually achieve what? To actually achieve subtraction. Let's start with what? Let's start with basic complement. Let's say we'll start with 9's complement. 9's complement. Now 9's complement is simply of a digit. 9's complement of a digit is simply that difference that would make that digit a 9. Let's say the 9's complement of 0. That's obviously a 9. Okay. The difference between what? Between 0 and 9 is obviously what? 9's complement of what? I want to say 9's complement. So I'll do this. 9's complement of 0 is 9. That is the number that would what? That you would need to complement 0 with to get a 9. 1's complement is obviously what? 1's complement is obviously 8. 2's 9's complement will obviously be 7. So it is the number that will need to what? That will need to add up to a certain digit. What? It is the amount that will end up to add to a certain digit to make it a 9. Now obviously we can see we can go all the way up to 9 itself, whose 9's complement will be what? Will be a 0. Okay, that's straightforward. Now let's put digits together. Let's say we have 127 and we want 9's complement of that. Okay, it is a set of digits. 9's complement, 129. 9's complement, I'll do this. 9's complement of 129 is that which will make these 3 digits a set of 9s. Okay, so therefore, as you can see, that will be an 8, that will be what? A 7, and that will be a 0. So 870 is therefore 9's complement of what? 9's complement of 129. I don't know if I need to do another example. 1073. Why I have so many 7s now? It's like this is the only complement I can do. I've got so many complements. It's like this. We've done one so many times. So let's try another one. Let's say 436. Let me rather do this. 436. 436. We want 9's complement of that. It is that. Let's say it was probably in a 5 here, for instance. Okay, let's say it was 4,365. It is that there is 4 bits here. It is that quantity that will make this a what? 4-bit set of 9s. All right. So what is that going to be? That's obviously a 5 here. So you can see you are just putting each digit's individual complement, 9's complement, and you're putting them together because the number is what is put together. So this here will be a 6. This here will be a 3. That there will be a 4. So 4,365 9's complement will be what? Will be 5,634. All it will do is, if you add a number to its complement, you just get a what? A set of 9s. That shouldn't be difficult. Now let's move on to what is called 10's complement. 10's complement. Okay, 10's complement is simply 1's complement plus what? Plus 9's complement plus 1. So let's say 0's 10's complement will simply be 0. Why? It would have been 9. 9 plus 1, yes, is equal to 0 carry 1. But we worry about the what? We worry about the 0, not the carry. Okay, so it will be 0. Let's take 1's complement. 1. 10's complement of what? 10's complement of 1. It would have been 8 for 9's complement. Remember, 10's complement, this is actually 9's complement. 9's plus 1. 9's complement plus 1. We're talking complements here. So this is 9's complement plus 1. So here it would have been an 8 for 9's complement. You add 1, that's going to be 9. Alright. If you try 2, 10's complement of 2, 9's complement would have been a 7. You add 1 to it, that would be what? That would be an 8. You can do that all the way up to what? 9. Now, this here, the 9's complement would have been a what? The 9's complement would have been a 0. 0 plus 1 is a 1. Right. Now, let's take the two examples that we used previously. We said 1, 2, 9, and you said 9's complement was what? We said 9's complement was 8, 7, what? 8, 7, 0. Okay, I can even do it there without even checking there. Right, but let's say now, what about 10's complement? We know it's going to be what? 9's complement plus 1, which therefore is 8. What call this? 7, 1. Because 870 plus what? Plus 1 will give us 871. So let's look at something interesting here. I will take what call this? The number 129 and the 10's complement 8, 7, 1, and I'll add them together. Let's see something interesting here. 9 plus 1, guess what? It's a 10. Okay, it's a 10. But then we know that what we do, we write the, I meant to say we write the 0 and we carry there. But we got 10 when we added there. Okay, now we come 1 plus 2 plus 7, it's another 10. Okay, so we write the 0, we take the carry next door. 1, the same way that every time we added here we're getting 9's, 9's, 9's. Here every time we add we're getting 10's. 1 plus 1 plus 1 plus 1 plus 8 is going to be another 10. Okay, even though yes, in this case here there's nothing else. So our answer would be That one will be considered the what? A carry. Our answer looks like it's zeros all the time. Okay, our answer looks like it's what? It's zeros all the time. But you know it was tens all the time. So that is why we say it makes sense was tens complement must complement something into a 10. So you can see everything there was giving us tens, tens, tens. So it makes sense now why we are saying tens complement is actually what? Nines complement plus what? Plus 1. This is nines complement plus 1 to get to tens complement. Okay. Now, I hope this is clear. Let me do the other example. I will repeat the 4, 3, 6, 5. And we say 9's complement, we already worked it out. 2, 5 here, 6 here, 3 here, and 4 here, because that would give us a series of what? A series of 9's. If you add a number to its own 9's complement, it will give us a series of what? Of 9's. Here, if you add a number to its own 10's complement, it will give us a series of what? Of 10's. Well, zeros really, but it's 10's. It was 10, 10, 10, 10 in each case. So now, if we look at that, if we add 1 to this, it will give us 10's complement. Okay, and 10's complement, infringing on the space for the what? For the other thing there. I'm infringing on the space for the tens complement. Now that will be, if we add a 1 there, that will be 5. That will be, we're adding a 1 to that, 3. That will be 6. That will be 5. We're not adding to the original number, we're adding to the 9's complement. 10's complement is what? Is 9's complement plus 1. Alright, so now if you look at this here, if we then do the same thing here, we take 4, 3, 6, 5, which was our original number, and we take 5, 6, 3, 5, which was our 10's complement, and you put them together. 9's complement would have given us what? This is 10's complement, right? 9's complement would have given us a series of 9's. Now, when you take 10's complement, now when you add, answer is 10, but we know we put a 0 and we carry the 1. That will be 7 plus 3, that will be 10. So now what we do, we've got 0, we carry the 1. Now it's 1 plus 3, 4 plus 6 is 10, and we get what? 0, carry 1. Now 1 plus 4 is 5, and plus 5 is 10, and there is nothing else. There is our 0, there is our 1 being carried. So what do you see? Every addition was a series of what? Was a series of 10's. In each case, we got what? 10 is our answer. So if you're going to have 10's complement, when you add each time, you're going to get 10, 10, 10, 10, 10. So I hope this is clear. 9's complement is simply, 10's complement is simply 9's complement plus 1. Now what I'm going to do, I am going to then demonstrate how we use this 10's complement in what? To actually achieve we are going to achieve subtraction via addition. Okay, we're going to achieve subtraction via addition. So let's take an example now using 10's complement. Okay, we'll start with 9's complement. Let's start with 9's complement. Use 9's complement to subtract via addition. Even if I don't say via addition, to subtract, I'll just say via addition because it's still new to people. So I'll say this is actually going to be through adding. Okay, we're going to do 2 examples. Then I'm going to say subtract 367 minus 120. Okay, first set. The second set is 1349 minus 220. 253. All right, so now What we first know is remember what you need to remember, complement the negative number. Okay, so the one that we are subtracting in this case is the negative number. So let's start with the first example. 367 minus 120. And what are we using? We're using 9's complement, and the moment you say it's negative, we complement. So we're using 9's complement. What do? The top number is positive, we do nothing to it. The bottom number we complement to 9's complement, so that we can what? It becomes positive. What do we then do? That is what? The complement there is 8. 9's complement there is 7. 9's complement there is 9. What do? We add. 7 plus that is 16. That is 7 plus 7, that's what? That's 14. 4 plus 8 is actually 12. One thing is you maintain the number of digits. So we have got 3 digits. So our answer is the one with the what? With the 3 digits. Our answer maintains the number of digits. So our answer is actually what? 246. But we have this bit here. Okay, this is called the carry bit. This is called the carry bit. What we do in the case of the 9's complement, we add the carry. Okay, how do we add the carry? All we do is take the carry and come and add it there, and our answer becomes what? This here is what? What am I doing? I don't even know what I'm thinking there. This here is actually 7, and this here is what? This here is, once we add that is 7, that one stays 4, and that one there stays 2, and our answer is, let's be fair, if you come here, 7 minus that is going to be 7, 6 minus that is going to be 4, and 3 minus that is going to be 2. So our answer and that one there is what? Only we don't do it here, we actually do it there. This is me just showing you that that is the correct answer. Let's do the other example to make sure we get this. 1, 3, 4, 9 minus 2, 5, 3. Okay, we subtract this. What do? The rule says complement. What the negative one, complement it. We're using 9's complement so that we can add instead of what? Of subtract. Now that stays 1, 3, 4, 9. I will do this without balancing the what? The digits here. To balance the digits here, I would have to put a what? A 0 there. But I will do this without balancing the digits. I want you to check something. If I complement this, this is going to be what? This is going to be 7. This is going to be 4. This is going to be 6. If we add this is going to be 15. Carry 1, obviously, that is going to be 9. That is going to be 10. That is going to be 10, right? This is going to be 2. And now if you look at this, there was no carry. There was no carry. We didn't carry anything. I'm saying there we didn't carry anything. Anyway, the rule of complements, when it's, so if we look at this, is this our answer? Already 9 minus 3 is going to be what? It's giving us 6. So this is definitely not our answer. There is no carry to add like in the previous what? In the previous, because this answer is wrong. So there's no carry, so we can't add a carry because we don't have a carry. Even if we did have a carry and we said we wanted to add anyway, it will be this will be 6 here. It will look like we're going if we added something there, it will look like we're going the right direction. This will be a 6, but this is a 9. As you can see, that is a 9. Okay, then here, what you get? You get if I'm adding this is a 9, this is a 0. But what do I get here? I'll get a 1. Already you can see that we are not going in the right direction either. So what do we do? Right, let's try the same example, but balance up the digits. We can see that this is wrong, so therefore we are going to remove this and try with what? To balance up the digits first. Let's see. I am doing this on purpose because I want people to be aware, to be very keenly aware of this. Now, if we are going to balance up the digits, that's a 0, and then now this becomes a 9, which makes a big difference over there. This will make a big difference in the previous addition, from the previous addition. Eh? So now when you add now, it's still going to be 15. All right. Now, this is going to be 15, so it's 1, 5. This is still going to be 9. This is what? Going to be 10. Am I right? Yes, 10. Okay, we didn't have a carry, so this is going to be 10, is fine. Now this is 10, 11. So if we maintain our decimal places now, you can see that we have a carry this time. Okay, when we take that carry now and we add it, because we said when you get a carry in with what? With the 9's complement, we add the carry. Okay, what does it mean? We add that carry there, and what happens? We have now a what? A 6. So this is not our answer there. All right, we are adding. Now I want to show that we are adding. I don't want to put the line. I was just saying is that our answer. Okay, so now you can see 6. That is 9. That is what? 0, and that is 1. Now let's see if we add this 9. We are subtracting here. 9 minus 3 is 6. We can't do 4, 5, so what do? We borrow from there, and you say this is 2. Then we say 14 minus what? 14 minus that is 9. Then you say 2 minus 2 is 0. Now it looks the same as that. And 1 minus 0, you can see that that our answer is correct. Well, we are actually not allowed to do this. It's a form of cheating. I'm just proving to you that our answer would have been what? Would have been is correct actually by doing it direct here, but you are supposed to do it only there, not there. All right, so this is how our answer, this is what our answer is supposed to be, and it is that. Now, what have you seen? Without balancing the digits, you obviously get the wrong answer. So what the first thing that you do is, the moment you're given a sum, please balance up the digits first. I will then go and do the same maths, but what I'll do is I'll reverse the numbers. I will make the 120 in the first example, I'll make it the positive 1, and I'll make the what? The 367 the negative 1. We said we complement the negative 1, and therefore the other one stays as is. We are doing 9's complement, so this is what? 6, this is 3, this is 2. And we are trying to what? Run away from subtraction, so that we add what the computer can do. Computer will use an add in this circuit. Okay, the so-called subtractor circuit actually has an adding circuit. All right, so when you come there and you say now, okay, what do you do? We're adding, this becomes a 2. What happens there? This with, okay, we're adding, so this becomes a 5. This is a 7. What do you notice there? Now we have no carry. I'll take this opportunity to highlight that with complements, with the rule of complements, every time there is no carry, you what? It means this answer here is actually what? Is not the answer. This is the what? This is the complements. This is the 9's complement. This answer is also in 9's complement form. When there is no carry, it means the answer is also in 9's complement form, meaning that it's what? It's negative, because the numbers that are complemented were actually what? Negative numbers. So the answer is in 9's complement form. What you do, it means the answer is negative, so you change the sign. What you then do, you recomplement, because you want it back. You don't want it in the 9's complement, you want it in the original complement of the. So obviously, if a number, 9's complement of a number is obviously okay, 9's complement of a number, whatever number you get from 9's complement is also 9's complement of the original number. So if what I mean here is for 1 if you look at 1, 9's complement of 1 is 8, but also 9's complement of 8 is 1. So what I'm saying is numbers are 9 complements of actually each other. All right. So what I'm saying here is the answer, if there's no carry, it means your answer is still negative. So it is in the what? It is in the 9's complement form. So to get the original answer, you know it has to be negative. So you change. It looks like you're changing sign, but sign was positive. You change the sign, and then you repeat 9's complement to get the what? The actual answer. So this here will be 7, and this here will be what? 4, and that there will be 2, and no. If you look at our answer now, it's 247. It was positive 247. It's negative 247. Yes, obviously, if I'm subtracting 120 minus 7, it's going to be the negative of 367 minus 120. Okay, which is true. So what I'll then do again, I'll come and prove that this is true by actually doing the other one as well. By doing this one here, we said here this was what? 253. And we are going to subtract 1, 3, 4, 9. What do we first do? We balance up the digits. Even though it's more relevant when you are talking about what? When the negative number is what? When the negative number is the one with the lesser digits. It's more relevant then. So we balance up the digits, even though in this case don't really help much, because when you complement, this is the number we complement. So we are using 9's complement for now. So our top number stays as is, and we complement that to 8, 6, 5, 0. We were trying to avoid subtraction so that our computer can use its adder. So this here now when you add is the 3. That there when you add it's a what? It's a 10. Now this line is a 9, 2, 6, and 1. Now this is an 8. What does it tell you? We do not have a carry. No carry. Telling you that this is 9's complement of what? Of the answer. Okay. What does it mean? It means the answer is negative. Every time the number is in 9's complement, it's because it was what? It was originally negative. So this number is negative. Therefore, what do we do? It's like we're changing the sign. We do 9's complement to get the original number. So this here will be what? 1096. So if you look at this, it's exactly identical to that. Obviously, if you swap the numbers, all that changes there is the what? Is the sign. This is 9's complement in action. I hope it's not difficult. I as much as I explained what is 9's complement and what is 10's complement, I want actually to what? Actually to highlight the differences here. Just remember 1, every time remember for A minus B, number 1 minus number B, every time A is greater than B, what are we going to have? We have a carry. So carry flag will be raised. We have a carry which we add to our sum. Okay. 2, every time, remember these important things, every time A is smaller than B, there's no carry. There's no carry. And answer is negative, and therefore in 9's complement form. What does it mean? I.e., that is, repeat 9's complement and change, or assign rather, change, assign the negative symbol. Answer is negative, ne? The negative symbol. Okay, so every time, remember that every time that you are subtracting what? A bigger number is taking out a smaller number, will have a carry and will add that carry with 9's complement. Every time that we are subtracting a bigger number from a smaller number, we will not have a carry, and therefore the answer is in 9. The sum here is in what? Is in 9's complement form, therefore it must be complemented again, and the sign, a negative sign, must be what? Must be assigned. That is basically what? That is basically how you do 9's complement. I think I would like to take a break and come back to for the 10's complement. I think it will be, the lesson will be too lengthy if I then do both of them together. Let me just give an exercise here. Let's say exercise. Use 9's complement to subtract. I'll give you one. To subtract 9,63 from 13,1, and then use 9's complement to subtract. I'll just give you this one example. The point here is I didn't do an example with commas, because I want, sometimes when you do things and you discover for yourself, it makes things even stay longer in your head. It makes them register in your head. Now, all you do is remember when you are dealing with addition and subtraction, you must align the commas. After you align the commas, you must then what? So this is going to be, we are subtracting the other one. So 13,1. What you're going to do is 13,1 minus what? Minus 9,63. Then you are going to even out the bits, make sure the bits are equal. Then this is the negative one. You're going to do 9's complement of that one there. And then when you've got a carry at the end, when you say you are adding the carry, you are always going to add the carry to the least significant bit. Okay, when you add the carry, you are going to take the carry to the least significant bit. Let me see if you can do this on your own, and I'll be impressed if you do. All right, then I'll come, and probably when I do the next exercise, I'll probably just give you the answer. Well, we know what the answer is. When you are done, without doing this, you must be sure that you get there a 7. Okay, I could have said, because I want to be consistent. We borrowed from here. That becomes a 0. This becomes a 2. And then 10 minus 6 is a 4. And then our comma is aligned. So 12 minus 9 is going to be a 3. So our answer your answer has to be 3,47. But see if you can achieve that using the complements. I've given you the hint. I've given you what you need to do. That shouldn't be a difficult question. All right, then. I hope you had fun. I did. I know I did. So, bye for now.